All right, here we go. Hold that thought, Randall. Hold that thought. We're getting there.
You know what? No, we're not going to hold it. We're talking about it. No.
So, more probs. It's still forward. We're shading to the right. We're shading to the right. Well, the left bound is 2, positive 2. Shade out. There it is. Roughly 2.28% of people are floating around with IQs above 130. Now, I heard, Randall, you were saying something awesome earlier. You said, wait a minute, it should be 5% because it's
2.5%.
2.5%. Oh, I thought I heard 5%. Remember that 95-ish, about 95% are within 2 standard deviations. That means from here to here is 2 standard deviations, yes? That means roughly 2.5 is in this tail, and the other 2.5 is in this tail. So I don't know what they would call below -2 or below 70. I guess that would be like inferior versus superior or something along those lines. Is that fair? You guys buy this? Ish. Say that again? Well, I like this. I like what you're asking right now, Aaron. The p-value. These don't have p-values. Technically speaking, we are showing you how to construct p-values later, but in order to have a p-value, you have to have a random sample drawn.
Okay.
And so until it becomes random sample inferential statistics, don't do that. Don't do that. It looks so happy.
It won't be if you keep doing
I know. But in order for us to have a p-value, it has to be a sample drawn from a population.
Okay.
This is the entire population. There's no uncertainty in it. We are certain that it's 2.3%. Speaking of it, somebody asked about a backwards problem. Let's do a backwards problem. So, 4 IQ scores, we'll make it up right now. 4 IQ scores. Let's find the 10th percentile. Let's find the 10th percentile for IQ scores. So let's do the same exact thing that Max did on his 2nd year checkup and his 3rd year checkup and his 4th year checkup and his 5th year checkup. Except instead of weights and head girths and lengths, we do IQs instead. So what's the IQ score that cuts off the 10th percentile? So do you see, first of all, do you see why this is a backwards problem?
Because we have the percentile.
Because I gave you the percent and I'm asking you for the IQ score. Now, my favorite part about this is you're going to see the pure backwardsness of the problem. What's the word for mathematical operations that are backwards? Remember what the word is? Inverse. It's actually we're going to be inverting a forwards problem. But it seems like backwards people seem to like the word backwards better than inverse. I like inverse because I'm a mathematician by training. But backwards, you're going to see the math we just did over there is going to be purely backwards. Remember the last thing we did over here? The very last thing we did over here was run the normal program, and it shaded an area, right? That was the last thing. So guess what the first thing we're going to do now is? We're going to shade the area. But don't use the program just yet. We're going to draw it first. We can use the program. We can if you want. We can. What's that?
We get to learn how to do this by hand.
Well, I mean, I think it makes sense to show it by hand. We can actually, I'm thinking that we should go on this board over here. No, you know what? No, I'm not. I'm not, and here's why. I'm not going to go over there. I was going to go add it to that curve over there, right? But why didn't I? I thought about it for a second, and then I said, you know what? Let's not go shade 10%. Why? Well, I could erase the shades. It's already there. Well, why wouldn't I shade 10%? So, for example, tell me when to stop. Tell me when to stop, if you will, Riley.
Because it goes
Too small.
that way.
Well, but that's okay. It's got to stop somewhere.
But you don't know what 10% is because you don't know how many numbers are over there.
Boom. Well, but it is going to stop somewhere.
At 0.
But that's 50%. If I stop here, it's 50%.
No, I mean 0, the numbers.
Oh, sure. But where if I stop here?
10%.
Exactly.
But where is 10%?
We don't know. It's undefined.
That's the problem, right? The problem is, I know if I stop here, I'm at 2.28%. Correct? If I stop here, I'm over 10%. I think I'm somewhere in the neighborhood of 21 or maybe 19 or something. So it's somewhere between here and here, yes? I just don't know exactly where. So what I'm going to do, I'm going to avoid having to be accurate, or precise for that matter. And I'm going to go straight to this curve, and I'm going to say, you know what? I don't know where it is, so I'm going to do this, I'm going to do this, I'm going to call it 10%. I don't know what that is. Can I figure out what that is?
Oh, yeah.
Yes. That's why I gave you. It's a very exciting sound over there. Oh yeah. I gave you a program that does this, right? Now here's the cool part. Remember how hold that thought for one. Give me 30 seconds, Riley. Remember how I told you you can figure out the forwards problems by making little tiny rectangles and shading them in, and then get it at. You can Riemann sums. You cannot manually do it backwards. In other words, you can't manually take the rectangles that are here and reverse engineer that z-score. You have to do it using computing technology. I love that. There are certain things in mathematics that cannot be done by hand. I find that absolutely fascinating. A non-invertible mathematical function. Totally rad. Please!
How can you determine what the lower 10% is if you don't know what the last number
No, Riley, you're overthinking this, friend. You're overthinking this. And the reason you're overthinking it, I love it that you're overthinking it, by the way. Taryn, it's the same thing that was upsetting you on Wednesday and last week. She was like, I don't get it. That thing goes on forever. It goes on forever. How can you log off 10% if there's technically no end at the bottom? And the answer, unfortunately, is hashtag calculus. That's why. Because when you take the limit of this function that is exponentially decreasing, the limit sums eventually to 0, even though no individual point does. I mean, if you analyze the an entire course, the Math 251 is devoted to this idea. If you take the limit of certain sums, the limit goes to a fixed value even if the sum goes infinitely. 252. Here's the idea, ready? If I drop this apple, it hits the ground, right?
No.
It hits the ground eventually. I want to eat it eventually, so don't let it.
Yeah.
But here's an argument for you, ready? Here's an argument. In order for the apple to hit the ground, it first has to fall half the way. Then the remainder has to fall half again.
But the ground.
Hold that thought!
No,
Hold that thought! Don't interrupt me!
No, the
Then it
ground
ha-
is a stopping point. This does not have a
Would you
stopping
listen to my argument? I'm trying to bridge the gap that you're experiencing here. Tim, it's going to help your. This is going to help your.
I get you.
You give me now. Watch this. Half. Half. Half.
Yeah, but
It's-
this is a stopping point.
Listen to me.
Yes.
If I keep doing it by halves, it never ever gets there because there's always half of a bit remaining, right? But what you've just proved mathematically is 1/2 plus a quarter plus an eighth plus 1/16 plus 1/32 plus 1/64 plus 1 infinitely. That goes off infinitely, never ends, correct? But it equals 1. Because you end here, you start here and end there. So an infinite sum can equal a fixed, what's called a convergent series.
So then what do you start, what number do you start saying is the stopping point?
It doesn't matter. It doesn't matter. These series exist. If you want to see the function, I can slap you the function on the board. It's not the most pleasant thing.
Yes, we want to.
Okay.
Oh, no.
Okay, no.
I've seen this before.
There we go.
Okay.
Wow.
There. That's the generator. It does. This is 1/2 to the n. But that generation gives you that curve. That guy has the same characteristics as the halving function, though. It's because an infinite sum can sum to a finite fixed value. Because of the same kind of logic I just showed you. Half of half of half of half will sum to 1. It doesn't, it's counterintuitive, of course. I'm not saying it's not counterintuitive. It's counterintuitive. I had to wrestle with this in my first calculus class because I'm like, wait a minute, you're telling me that it goes on infinitely, but I can treat it as though it doesn't.
Because it gets so small.
Right, it gets so small, but Riley's going to counter this correctly, by the way, but there's still something there. There is still something there. But more importantly, there's more here. And that's the fixed point. Essentially, going from the 9th to the 10th standard deviation doesn't add any measurable bit of area. You saw that earlier when I said, give me some numbers, and you said -10 to 4. And then you said -4 to 4, and it was the same 1. It's different, but in the hundredths of a millionth of a decimal point, right? Riley, see what I'm getting at, friend? I'm not saying it makes perfect sense at first. That's why they have an entire calculus course devoted to it. Believable? That's okay, you don't have to. You don't have to. Lily, go. I did, shoot, we didn't stop this one though.
There we go.
I'll tell you what, try this one for next time. Bring this one back for next time. Try to find 10th percentile. Well, no, you know what, time out.
Minus 1.2.
Let's do this. Let's finish this now. I'll bring the other thing I was going to show you at the class next. That makes more sense, I think.
Yeah.
Let's finish this one. Let's knock this one out. So, to find the 10th percentile, what I need to know is what the z-score is. I can figure that out with the program I gave you. And thank you, brother, for that question. It's a very good one. Now watch this, watch this. It's going to upset you a little bit, Riley, and rightfully so. It's good that you're upset by it because it doesn't make it doesn't make super intuitive sense. It's a backwards problem. We're going to shade to the left 10%. Now Riley's question, it's a very good, where does 0 start? It's a great question, but it's not so much where does 0 start, it's where does 10 stop. It's where does 10 stop, and 10 stops at negative 1.28. 1.28. That's the z-score it stops at. So hold that thought. We're gonna, we'll finish it up in 2 minutes here. We now know the location of the z-score, which means we're now over here at negative z is negative 1.28. So the camera can see it better. We've got to convert that back now. Yes. Now remember, mu is still 100, and sigma is, that's a sigma, is still 15.
So it's negative 1.28 minus 100 over.
Careful, careful. Where does the 1.28 go? It goes here where the z is.
Oh, okay.
So
So it's, and then
it's negative 1.28 equals
x minus 100
minus 100
over 15.
over 15.
Uh-huh.
You can't, you gotta put it in the correct place.
Uh-huh.
And now we just reverse engineer it. 15 times that bad boy,
X,
Good old algebra.
plus a little bit of algebra, a little tiny bit of algebra. Never killed anybody.
It's the reverse.
That's about,
19.2? Negative 19.
Maybe 19.2.
thank you guys. I was gonna guess at a 20, you gotta give, negative 9.2 is better.
19.
Negative 19.2 plus 100, which means we'd have to get just over 80, it looks like. 80.8, about 81-ish. 81 on an IQ test is the cutoff for the bottom 10%. Anything below that, you're in the bottom 10% of IQ scores. That's it. That's it. It's a backwards problem. You're just working backwards from the. I got more of these planned for Wednesday.
It feels like a Lego.
It feels like a what?
A Lego.
It's exactly that. You're working a Lego model. You're built it and you're taking it apart again. Exactly the same thing. Fair?
Are we doing it on?
That's totally fine too.
Are we doing it on class quiz on this?
Yeah, we'll do the in-class quiz on Wednesday. I'm sorry we didn't get time. I wanted to do more of these, and I got even more planned for
Can I move
Wednesday.
this now?
Yes, you may, of course.
I'm a big that doesn't fit all the time.
I do promise. I do promise. I did, and I'm a lion.